Hi there, Mr. Sutton with the IM3 Honors 1-4 Extra Practice Number 1 solutions on inverse functions.
To find the inverse of the h function on this, we have to switch the x and the y values first. So we have x equals negative 2y cubed. Next, we solve for y. So if we divide both sides by negative 2 first, we've got a negative x over 2 on the left side. And then to get y by itself, we just cube root both sides. So we can write h inverse equals the cube root of negative x over 2. Finding the inverse of this function here is actually a decent number of steps, although it doesn't look like it should be at first. So we'll start by switching x and y. We'll write x equals 2 over negative y plus 2. A few things we could do at this point, but I think the easiest is going to be to switch the fractions around so that y is not in the denominator. So I'm just going to flip both sides. We'll write 1 over x on the left side and negative y plus 2 over 2 on the right side. I just took the reciprocal of both sides there. Now I'm on a little bit more comfortable ground. So let me get rid of the fraction on the right side by multiplying both sides by 2. So we can write 2 over x equals negative y plus 2. Now we can get negative y by itself by subtracting 2 from both sides. So we have 2 over x minus 2. And then we're not quite there. We just have to subtract, or actually a multiplier divide by negative 1 to both sides. So I can write y, or in this case f inverse, equals negative 2x plus 2. Notice that I multiplied both the 2 over x and the minus 2 by a negative 1. For this problem, we're trying to find the inverse for the g function here. I'll start by switching the x and the y values. So I'm going to write x equals 1 over y minus 1. And then I'm going to solve for y. First step to doing that is to add 1 to both sides. And now to get y by itself, we can't have it in the bottom of this fraction. So what I'm actually going to do is take the reciprocal of both sides of this equation. So I'm going to write y, or at this point I guess I'll call it g inverse of x, equals 1 over x plus 1. So again, I just flipped both sides and replaced this y with the g inverse. For this problem, we're trying to figure out the inverse of the f function or state that there is no inverse. Now, this is one of those where you hopefully recognize that this absolute value prevents us from having an inverse. Because that's going to break the horizontal line rule. Also, we don't know what got plugged in to give us the output, because absolute value makes negatives and positives both positive. So either way you look at it, with the absolute value, we have no inverse. On this problem, we're trying to find the inverse of the f function here. So to do that, let me start by switching x and y. I'll write this as x equals negative 4 plus the 5th root of 16y all over 2. And now I have to solve for y. First step, let me get rid of this fraction by multiplying both sides by 2. And then let me add the 4 over to the right side, the left side, so I can isolate this 5th root. Next, I have to get rid of the 5th root. I'll do that by raising both sides to the 5th power. I just have to be careful and put this whole 2x plus 4 in a parentheses when I raise it to the 5th. And that gets rid of the 5th root on the right side. Last step, I just have to divide by 16. So I'm going to write y, or actually at this point, f inverse equals 2x plus 4 quantity to the 5th all over 16. To find the inverse on this problem, let me start by switching x and y. So I'll write x equals negative 2y plus 3. And then we'll go ahead and solve for y. First step, we'll just subtract that 3 from both sides. And then I have to divide by negative 2. So I can write f inverse equals negative x minus 3 all over 2. Or you could have the negative in the denominator with the 2, either way. To get the inverse for this function, we'll start by switching the x and the y, the input and the output. So we'll have x equals 1 plus y plus 2, quantity cubed. Now we just have to solve for y. First step to doing that is subtracting 1 from both sides. Now we have to get rid of the cube here, so I'll cube root both sides. I'll have the cube root of x minus 1 over on the left side. Next, we have to subtract 2 from both sides, so we can write y, or in this case now f inverse, equals cube root of x minus 1, all of that minus 2. For this problem, we're trying to figure out the inverse for the h of x function. That's actually going to be impossible, though. Because of this even power here, this is actually going to fail the horizontal line test, or another way to think about it is negatives and positives are both giving me the same answer on this one, so this has no inverse.